Hey, Math 3-2s. We're going to do the next part of this one, part 3 of solving. And then right after these 2 pages, I believe, we'll do the graphical one in the next lesson here. So we're going to apply what we just did to help us solve these equations now. These equations have equal signs, so there should be an x value that satisfies this equation that I can put in there to make the left side equal to the right side, or the left side equal to the right side. Okay, so let's see. We have 2 bases. I have a base 3 and I have a base 81. So I'm going to look at the 81 and say, can I change that to base 3? Okay, maybe I can. So can I change the 81 to be a base 3 number? I'm going to leave this one over here alone. So we already had this one before. 81 is base 3 is 3 to the power 4. You can just go back to that chart. 3 to the power 4 is 81. Yep. Okay, so this is base 4. And because the bases are exponent 4, since the bases are the same, I can drop the bases and say x is equal to 4. Okay. Now, if they get a little bit trickier, like I was saying, so you get the first thing you want to do is get the term by itself that has the exponent. So this whole thing right here, you want to get by itself. It already is, because it's all by itself. There's no pluses or minuses around there. So now what you're going to do is you want to get rid of the 4. So I'm going to divide both sides by 4 and just see what happens. Okay, so let's divide both sides by 4. I think I can divide 256 by 4. Hopefully I can. Yeah, I get 64. Okay. Sometimes that doesn't work out the best for us, but in this case it did. Then what I'm going to do is I'm going to change this 64 to 2 to the power of something. So I go up to 64 of the chart here, where actually the 2 ones go across. 2 to the power of 6. Or just punch in your calculator, 2 to the power of something until you get to 64. If you skip past 64, then you can't do it. But 2 to the power, oh, what was it? 2 to the power of 6? Got distracted. Yeah, 2 to the power of 6. So I just typed in my calculator there. You can see 2 to the power of 6. 24, or 64, sorry. Okay, so now the base is the same. I can drop the bases and say x equal to 6. There you go. Now they get a little bit more tricky when you have weirder exponents like this one here. Like these ones here, there was only 1 power, so we isolate for that power, we change the base. It's pretty good. If you have 2 powers, like in C here and in this one down here, B, there's multiple powers here, that B one's actually pretty difficult. You're going to isolate for each power on either side of the equation, then change the bases just like we did. So this would be 3 to the x. I'm just going to leave that one alone. I'm going to change the 9. Remember, you always change the bigger one to a smaller base. So 9 is 3 to the power of 2. Now, and I just know 3 squared is 9. Okay, so we're going to use that, and this is the exponent law where it says power to the power, so we're going to multiply that in. So this is like a distributive property, there's little brackets around that. You got to make sure that 2 gets distributed to both the x and the minus 1. So it'll be 2x minus 2. Okay, so now the bases are the same. Since the bases are the same, what we're going to do is we're going to drop the bases, and then we're going to solve this equation. So I'm just going to rewrite it up here. Okay, so I'm going to minus the x over. Now I always like to move the x's towards the bigger one, so like this 2x and x. Let's move everything to the 2x side, because that leaves the x as a positive number. But it leaves a 0 on this side, that's fine. Then I'm going to move this over here. I'm going to add that 2 over. So x is equal to 2. Yep, seems like it works in my head here. So 3 squared, 3 to the power of 2 is 9. Then 2 minus 1 is 1. So 9 to the power of 1 is 9 as well. So that does work out. Cool. When it's not like rational expressions where you get like extraneous solutions. You just get solutions here. They should work as long as you did all the steps correctly. So you don't necessarily have to verify these ones at the end. It's good to do that just to double check to see if you did your steps correctly, but you don't necessarily have to. Okay, so this one here I only have 1 power, so this is 9 to the power of x, x minus 2. So what I'm going to do is I'm going to add this 8 over to the other side. So 73 plus 8 is 81. Okay. I don't have a 9 thing here, but I do know that 9 times 9 is 81. I do know that. But another way to do this, you can also just change both these bases to something smaller. Like I see 9 and 81. If I go to this chart up here again, 9 and 81 are in the 3 base column. So here's 3. There's an 9 right there, and there's an 81 right there. All right, so they're both in the 3 column. So I could change them both to base 3, and then I can compare them. But if I were to expand this down a little bit more, 9 squared is 81. So we could just do that as well. I'll show you that both work. Maybe I'll do both here. Okay. So I'm going to do the easier one first. 9 squared is 81. I'm going to drop the base. And then I'm going to add the 2 over x equal to 4. Okay? Not too bad. Then what I could also do, I want to just verify, does it work the other way? So if I change into both base 3, so 9 is 3 squared, and 81, we already did this one before, is 3 to the power of 4, right? We're going to do the power to the power here. So this changes into 3 to the power of 2x minus 4 is equal to 3 to the power of 4. I drop my base. Yeah, get the same answer both ways. Okay. Now this one here, this is a bit trickier to do. None of these are the same base, but it's very similar steps to what I was just talking about before. 248 and 128 are all in the same line here. 248 and 128 way over here at power 7. They're all in the same line. So they can all be changed to base 2. So that's what I'm going to do. I'm going to change them all to base 2. The first one I'm going to leave alone. This guy I'm going to change to 2 to the power of 2. This one I'm going to change to 2 to the power of 3. And this one over here I'm going to change to 2 to the power of 7. I think that was right. Let me just go back and double check. 2 to the power of 7, 128. Power 7, yeah. Cool, cool. Yeah. So now I'm going to use my power to the power rule. So I got 2 to the power of x plus 1. That's not going to change. Then here I have 2 to the power of 2x plus 2. So remember that you're going to do the whole distributive property. When you multiply these out, you got to make sure to multiply it to both those pieces. So this would be 2 to the power of 3x plus 3. And this one's going to be 2 to the power of 7x. Okay, so they all have the same base on this side. So remember one of our rules, if you multiply terms together that have the same base, you add your exponents. So I'm going to add my exponents on the top here. So this is going to be 2 to the power of x plus 1 plus 2x plus 2 plus 3x plus 3. On the other side I said 7x. Okay. I'm going to group my like terms. X plus 2x plus 3x, 6x. 1 plus 2 plus 3. 1 plus 2 plus 3, 6. Okay, cool. Now we have a power equal to power. They both have the same base. So we're going to drop our base at 6x plus 6 is equal to 7x. Then we just rearrange this equation. So I'm going to minus over the 6x to that side over there. 7 minus 6 is 1. I'm just going to write that way up here. So I have 6 left on that side, and then I have x on this side. So x equals 6. Now remember, you can verify that by storing 6 into your x variable and then typing exactly what's written on that side to see if it works. So maybe I'll do that. Do I have enough time for that? Oh yeah, I have some time. This video is a bit shorter. Okay, so my face is going to get in the way here. That's fine. I want this right there. There you go. And I want this on here. Okay. Okay. So we found x to be 6. So I'm going to go 6 STOX. So I'm going to store 6 into the x spot, and then I'm going to times in, or type in exactly what it says there. So 2 to the power of x plus 1, use a little get out of that, okay, times 4 to the power of x. You could just do this mentally too. These will all be 2 to the power of 7 essentially. Times 8 to the power of x plus 1. Hit enter. So that's what that side is. It's a really big number. The other side should be the same. Yeah, they end up being the exact same number. So that is a correct solution. Cool. We have a few more here. I can do a couple more before this video. Nah, I'll just do this page on the next video. And I'll see you then.